So we have 6 episodes on behind building the working RAG pipeline. But now, do we know if this is good enough for the production? Manual testing doesn't scale, and you ask a question, check the answer, and maybe try 5 more examples and call it done. That approach cannot catch regressions than you tweak a prompt or swap a model. This episode introduces an automated evaluation framework that grades our pipeline like a teacher grading homework. RAGAS uses a judge LLM to score for metrics. Faithfulness checks if the answer is supported by the retrieved answer. Relevancy measures how directly the response addressed the question. Context precision ensures the most relevant chunks rank at the top, and context recall verifies they fetched all the necessary information. We will build a golden dataset with the test questions and expected answers, run the evaluation against our live API, and save a baseline snapshot. By the end, one command prints a scorecard and writes an eval baseline.json, the regression gate for future changes. Start with stack with Docker Compose up. Postgres, Redis, and FastAPI are already running from episode 6. The script loads eval golden.jsonl, a file containing 23 test questions with ground truth answers. The script sends HTTP requests to ask endpoint and retrieve endpoint for each question, collects the answer and retrieved chunks, then hands everything to the judge model. The judge is GPT-4 Mini and it scores the results on 4 metrics. Faithfulness comes in at 0.92, answer relevancy at 0.88, context precision at 0.85, and context recall at 0.90. The script writes eval baseline.json with the timestamp, sample count, and the 4 metric scores. The test loads the baseline and assets that all metrics are above 0.80. One command produces a repeatable quality snapshot. Future prompt or model changes will compare against this baseline, so we catch regressions before they reach production. We walk through 3 files: the golden dataset, the main evaluation script, and the scorecard formatter. Open golden.jsonl again. This is the JSONL file, one JSON object per line, with 23 test cases derived from sample frac.md and from sample policies.md. Each row has an ID for tracking: a question with mimic a real user query, a ground truth field with the expected correct answer, and a category label. Factual examples include: what steps do I take if I forgot my login password? The ground truth describes the reset flow from the frequently asked questions. The ground truth cites the 30-day window from the policies. Negative examples are out-of-domain questions like: what is today a Bitcoin price? The ground truth states the knowledge base has no information about cryptocurrency prices. Negative cases ensure the system gracefully refuses unanswerable prompts instead of hallucinating. Now open RAGAS run.py. This CLI script orchestrates the entire evaluation flow. The load golden function reads golden.jsonl, validates that every row has a question and ground truth, and raises an error if any row is malformed. The collect predictions function uses the HTTPX client to send HTTP requests to the live FastAPI stack, not isolated Python functions. For each question, it posts to ask endpoint to get the final answer and posts to retrieve endpoint with the top case set to 5 to get the retrieved chunks. It collects 4 lists: user input for the questions, response for the answers, retrieved context as a list of chunks text per question, and reference for the grounded truth. These names map to the RAGAS schema. Older tutorials use deprecated case like question, answer, context, and ground truth. We use the modern schema that current RAGAS versions expect. The run RAGAS function wraps our OpenAI models with LangChain LLM wrapper and LangChain embedding wrapper. This wrapping is mandatory in current RAGAS versions when we use the long chain models. The judge model defaults to GPT-4 Mini, but you can override it with the model flag or with the LLM model environment variables. Embedding use the text embedding free small. The function calls evaluate with 4 metrics. Faithfulness is the generation metric that checks if the answer is fully supported by the retrieved chunks. It penalizes the hallucinations. The answer relevancy is the generation metric that evaluates how directly the response addresses the user question. It penalizes the incomplete or off-topic answers. The context precision is a retrieval metric that measures if the most relevant chunks are ranked at the top. It's a high precision means the generator does not have to sift through the garbage. And the context recall is a retrieval metric that checks if all necessary information to answer the question was fetched. It flags blind spots in retrieval. So this is the LLM-as-a-judge pattern. Instead of exact string matching, the judge model understands semantic meaning. Correct answer phrased differently when the ground truth still scores high. The RAGAS result object supports dictionary-like access. Our script safely extracts metrics using the repredict or dictionary case, which robustly handles recent changes in how RAGAS returns evaluation results. Open scorecard.py. The format metrics function normalizes the RAGAS output into the stable JSON payload. Created it with ISO timestamped, num samples with the count, and metrics as the dictionary with the 4 scores rounded to 4 decimals. The write baseline function writes the scorecard to baseline.json and creates the parent dictionary if it is missing. The print scorecard function prints a human-readable summary. Faithfulness 0.92, answer relevancy 0.88, context precision 0.85, and context recall 0.90, samples 23. The CLI supports 2 useful flags. The limit flag caps the number of the golden samples, which is useful for quick smoke tests during development, and the skip evaluate flag collects predictions without calling the judge, so you can iterate faster on HTTP collection logic. Judge-based evaluation takes time and consumes API credits because the judge model makes multiply LLM calls per question. The limit flag helps control costs during the iteration. Tracking both retrieval metrics and generation metrics pinpoints where a failure occurs. If an answer is wrong but recall is high, the prompt of the generator is a fault, not the database search. In production, this baseline script runs on pull requests. If code change drops context recall below a threshold, the build fails before merging. Alternative frameworks like the TrueLens and DeepEval offer similar capabilities. We choose RAGAS for its tight long chain integration and clear metrics definition. We build a golden dataset with 23 test questions covering factual, policy, and negative scenarios. RAGAS evaluates the live API with 4 metrics: faithfulness and answer relevancy for generation quality, context precision, and recall for retrieval quality. One command uv run python -m eval.rags run produces a scorecard and writes eval baseline.json. This baseline is a regression gate. Future prompts tweaks, model swaps, or retrieval changes will compare against today's score. Next episode, we will use this baseline to safe experiment with prompt engineering and model selection. Automated evaluation replaces manual testing, and the baseline snapshot gates future changes. If you found this video helpful, learned something new, or discovered ways to simplify your workflow, boost your productivity, or even save money, please subscribe my channel and hit the like, because it really helps me to grow and keep digging to discover new things and continue creating more content like this. Also, leave a comment below with your thoughts, questions, and experiences. My goal is for us to learn, grow, and build real AI expertise together, and your feedback is an important part of that. Thanks for watching, and see you in the next videos.